Hey everybody, Dave Lindberg in Hong Kong with another episode of THD Podcast. It's our weekly podcast talking about whatever audio technologies that we like and want to talk about. So please, I hope you're subscribed to this channel. We do this every Monday at 9:15 a.m. Eastern. Tonight's guest is a company headquartered in Italy with a factory in China. So they bring the expertise of Italian engineering in loudspeakers, which these guys tell us is the best in the world. So we're going to find out all about that. This is kind of a virtual factory tour on this episode. So please note you'll find out all about what they do and how everything's made and all their QC processes. So without further delay, please enjoy the podcast. So joining us, as always, is our co-host, Mr. Simon Weston. How are you doing this evening, Simon?
Still in Japan, so can't complain.
Yeah, all right. And Tom Janes, the Business Development Manager for the Americas, joining us from the Kentucky area of the U.S. How are you doing today, Tom?
Doing well, Dave. Thanks for having us on today.
All right. Yeah, great to have you. And Kevin Shove, the International Sales Director of LaVoce, based in the U.K. Hey, Kevin. Nice to have you on our show. How's it going?
Yeah, good. Thank you. Yes. Yeah, very good. We're very pleased to be doing this with you guys.
All right, that's great. So, LaVoce, we see them at the NAMM show and the big speakers kind of out on display. And I think there's a history in automotive with a headquarters in Italy and now a presence in China. Maybe Kevin, you could tell us a bit about the history of the company and maybe run through a presentation, give us some talking points to jump off from.
Yeah. No, absolutely. I mean, LaVoce, I think, arrived on the scene as a brand in 2012, but our heritage goes back a lot more than that. But I know our competitors have been keenly watching what we've been up to, especially over the last 5 years or so, because we've kind of engineered ourselves to be a really serious player within the transducer market. And so we're enjoying some success and obviously challenges along the way. So it'll be good to kind of explain our company in a bit more detail.
Okay. Would you like to run through some slides?
Yeah, sure. Let me just get this up and running. Okay, cool. Well, listen, LaVoce is our brand name, and it means the voice in Italian, but it's also the name of our facility in China. In this slide, you'll see innovators by tradition, and this was a hook line that we took on at the beginning because we're not just 10 years old. You know, our parent company is nearly 35 years old. So we're not the new kid on the block as much as people think we are. And also recently, the Pure Potenza line here is really a nod towards our R&D center in Italy because it's based. Our HQ is based in Potenza Picena in Italy, and so we want people to understand that we're really designing Italian, design products, but manufactured at our facility in China. So, and in terms of what we produce, we are really focused on the pro audio industry and the MI industry in terms of supplying higher power transducers for anything that's kind of a portable product install or touring sound system for high capacity venues. So, So why don't I dive straight in? So as I mentioned, we have two companies, Elettromedia in Italy, nearly 35 years old, and their history really spans back to mobile electronics, so car audio, but they now engineer amplification, speakers, cabling for anything that moves, basically. So they do motorsports, motorbikes, marine speakers for boats now, because they're all associated. And Elettromedia is really the heart of our business. So we have our R&D center there for all of our business. And it's also the strategic head office for LaVoce in terms of our planning and input for sales and development.
Is there any production in Italy still at all?
No, and our company may have done some production in the early days, but it's always been a design engineering house, if you like, and then outsourcing to third-party manufacturers, which is an interesting point because that's where Lavoce came from, really. We were our company in Italy was focused on the car audio industry, mobile electronics, and outsourcing their designs for speakers and transducers. And decided that actually, if we want to become very successful, we should make our own. And so through obviously lots of contacts in the industry, we partnered with a very big transducer manufacturer in China who specialize in kind of small transducers. I mean, I don't know what their turnover is, but it's huge compared to us. And they really helped us out in terms of setting up a production plant in China in partnership. But the really important thing is that in 2016, our president bought out that shareholding by this Chinese company, which they were perfectly happy with because we were small fry compared to their business interests. And so when we're pitching to our customers, it's a really important point that we own our facility, our production facility in China. It's a wholly owned subsidiary of our Italian company. So it's Italian manufacture, European production standards, but in China. So we offer all the logistics and cost benefits of Chinese manufacture.
Okay.
And this production this production plant is 100% transducers only. We don't make any finished goods.
Okay, and that's just so everybody knows, that's not far from Shanghai geographically.
Exactly. Yeah, it's in a city called Jiashan, and it's a really high investment city. It's just had a speed rail put in between Pudong and the city centre. So it's a good resource for staff and components actually.
Okay, yeah.
And so just to summarise, at this facility we manufacture our own car audio speakers and obviously the pro audio speakers that we pitch for our Lavoce project, if you like.
Okay.
So in terms of the products our group manufactures, our mobile electronics division is completely dedicated to our own brands. So we don't build for anyone else. And our brands are Hertz and Audison. And they are pretty much revered in the industry as being innovators for technology and moving the market forward. And, the product's very elegant, very car audio, but it's Italian design and very well received as a leader in its mid to high end positioning.
Okay.
And in terms of Lavoce, we manufacture woofers mid range, anything from 1 inch up to a 21 inch subwoofer, and we have probably around 150 products. So this is our core business, but for Lavoce, we're not really involved in the car audio side of the business. It's a different division managed by a whole different team. So me and Tom are completely focused on just the pro audio transducers.
Okay.
Do you think that the design parameters for car audio differs significantly from pro audio? Is there much crossover?
I think it's different in terms of its application because obviously cars have a different space to manage, to try and get the positioning and the staging and the acoustic performance differently. So and we're obviously also building electronics as well. So it's a slightly different mindset, but in terms of the acoustic standards, in terms of what we're trying to achieve, they're similar. We're trying to make high quality premium product that looks good on paper, but also looks sounds fantastic when it's in its application. So we share. We have a team of R&D. We'll talk about our R&D team soon, but they tend to share. They could work on a car audio project, or they could work on a pro audio project.
Okay.
We have some dedicated pro audio guys, but there are some that might float between both divisions because the goals are very similar.
Mm-hmm.
But it's just that where the products end up are obviously different and have slightly different challenges. So this is a picture of our company in Italy. As I say, it's nearly 35 years old. And we employ around 75 people here, and it's the heart of our R&D and where we make our strategy, if you like. A key point here is in 2019 we spent a significant amount of money developing our R&D facilities. That's for our own benefit, obviously, for our own brands, but also for our customers, because we want to be seen as a centre of excellence when it comes to R&D and engineering capability, especially when we're trying to sell to some big name pro audio brands. They have to know that we have all the resources and all the technology and the spaces and the measurement facilities that we can do that at our base in Italy. So it's an impressive place.
Okay.
So in terms of the team there's a couple of pictures of the internal of our R&D space. We have a dedicated research team. So this is really important because obviously we have electroacoustic engineers who do a great job, but we've also got a dedicated team that we task with, improving our ability to enhance product performance or development, tools within the company. They're all PhD based level guys that are far more intelligent than I when it comes to this kind of stuff. But well, we're very lucky because we've also got a good pool of talent in Italy. Ironically, Italy is really the home of transducers. If you looked at where most of the bigger brands come from in the pro audio industry, it's Italy. Right. So there's a good pool of resource as well. We have obviously lots of design tools, lots of software available. We use Comsol a lot as part of our simulation software. And Tom, in a second on the next slide, we'll talk a bit about some customized applications that we've developed ourselves, to emphasize our ability with this system. And of course, we use other typical tools. If you're in the transducer design world, most of these are quite familiar. All our competitors, I'm sure, will have all of these kind of products from
and just
LoudSoft
kind of
and Klippel.
Perhaps an odd question, but it seems like for automotive, you'd probably get you have a lot of restrictions on the size of where you can put the transducer. So you're engineering with some restrictions. With PA speakers, you're kind of engineering to optimize performance. So it's kind of a slightly different mindset. So back to what Simon asked earlier, it sounds like it'd be kind of two different directives on developing for automotive versus like a PA or amplifier, like guitar amp type application, would you say?
Yeah, absolutely. Yeah, I think in terms of their application, they're very different. Cars are quite restrictive in what can be achieved. Space is limited. You're inherently very close to speakers and so forth. So in that respect, yes, definitely. When we're designing the components, we obviously still have pretty much standard or directives or targets to achieve in terms of their quality, performance, expectation, but maybe they're shaped slightly to meet a slightly different enclosure or positioning in a car and so forth. So yeah, it would be a different approach, but that would be part of the product brief when the guys start the development.
Right. Okay. So
as I say, we use common tools, LoudSoft, Comsol, Klippel, as part of our development process. And what's really, really important when we're talking with, our customers, especially our pro audio brands, we want to take on a project, develop the project, and deliver a simulation, if you like, of their target parameters in the fastest and leanest way. And that's where this Comsol system has really, really done wonders for us. So I'll just flick over to the next slide and then over to you, Tom, to give us a little bit more background on this, this system.
Sure. And if my gray beard does not date me, my comments now will. I started this. I'm a transducer engineer myself, despite the business development role, and so I've been doing this since 1986. And the industry's come a long way. The tools have come a long way. My initial software resources were an RPN calculator, if you're familiar with those, the old, reverse Polish notation calculators. We pulled data in from tables and nomographs, and manually punched into handwritten programs. And now we look at what's available today. COMSOL, of course, has kind of become the industry standard for modeling. And of course, you can model many things. You see, we've got 4 specific areas here. There's also thermal modeling that's available, and structural modeling with the basket. The beauty of what LaVoce has done is integrate all of these, so that in the past you would use a particular program, you would pull data from that, try to translate it, maybe use Excel and handshake between programs. But COMSOL is a multi-physics application. I'm sure you guys are aware of the company, and like companies, there are competitors out there, and it's just significantly reduced the time to market with a new product. The beauty of what our team has done is there in the second bullet point, is we have a GUI that's driving the front end of COMSOL, so that each engineer, COMSOL is a learning curve if you've used the program. And so this enables any transducer design engineer to input data into the COMSOL engine room, if you will, and be able to get results quickly without having, to be a PhD software engineer, which we have on staff. That's who's written our programs for us. Very, very nice resource to have. And so, starting with the top right, you've got electromagnetic design. Again, years ago, you would do, once the advent of fine element modeling would come about, you would take that and then you may hand that over to another program. But, with our capability here, especially for a new product, I'll say that, if you've got an existing product line and you want to make a tweak, we all know that's, pretty easy to model. But if you're starting from scratch and you're designing a new product, say a new voice coil platform for some of our larger subwoofers, you don't have a baseline to work from. You have material properties, and with everything being integrated here, any change that you make to the motor structure, you can then look at how that affects the impedance plot, the inductance, obviously, thermal management. And then, the bottom 2 there are suspension and vibroacoustics. So we can, predict the response of the loudspeaker based upon co-materials. And if you're working on a specific project for, customers ask you to do something very detailed, say he has a system performance specification for a subwoofer. He wants an F3 of, 35 in this box. Well, as you see, in the lump parameters window there, you can actually do that in COMSOL, and the information is available in the integrated app. And so we can design the speaker to his performance targets instead of, throwing it across the wall and letting him model that. We know ahead of time. And the beauty of this thing is, we're talking 95% accuracy with this new method. I don't know.
Tom, COMSOL is actually a general purpose modeling tool. It's not specific for speakers. Is that right?
That is correct. That is correct. Yeah. Many industries use this software.
Yeah. So what you actually do is you have to build your own interfacing or framework to run it.
Right.
Yeah.
Right. Yeah. Or again, I've used similar programs, and you're just pulling up. Once you have the CAD in there, you have to identify everything, material properties, and input a lot of information. And that's what this GUI does for the team, is it minimizes the pain of having to get everything set right. We've got some specific material properties and some blanks to fill out for, to input this, once you have the 3D CAD in there. So it's when I joined the team, I was meeting with the PhD engineer, and I just looked at him and smiled, because this is like the holy grail of speaker design. I wish I'd had this tool years ago. I've worked in automotive, I worked in PA and some consumer products, and this is it. it significantly shortens, your period to get to a product, and again, only a 5% error. So it's really amazing that this capability is available for us to develop product in this manner.
Okay.
Yeah, no, and definitely from a customer perspective, if we deliver them a simulation and they say, yeah, we like it, we absolutely want to deliver a physical prototype that is, that replicates that, because that's the skill set, that's the trust that they, we want them to have in our development capabilities. So yeah, this is a really, really valuable tool. And the team, are using it every day.
And it's, when we say 5% error, the production tolerances for a transducer can be, 5 to 10. So that's how accurate it is. Just due to component tolerances.
Yeah, absolutely. Yeah, and just one other thing. I think the other thing that's really useful is that you can do a virtual prototype, but actually we can simulate many or an infinite number and overlay the results to really do a fast comparison. So it's really, really, really useful.
And so what kind of key outputs do you get from the console simulation? Frequency response, or what? Yes. I mean, that would be the obvious thing. Is there other characteristics?
Sensitivity, till small parameters, for system design. And of course, the vibroacoustic design. You also get bottom left, there's suspension. You can see what the maximum excursion limits would be, and optimize that for that particular application. Yeah, everything here is driven by the target of having linear motion of the voice coil and behavior of the membrane, the cone or tweeter dome, in this, whatever the case would be.
So that's very interesting. You can actually derive the small parameters from that simulation.
Yes.
Mm-hmm.
Cool.
Okay.
All right.
Well, another part of our investment in the R&D center was to set up our Acoustics Laboratory. And this is a dedicated space so that we can measure loudspeakers behavior using some tools from Clipple, one being the R&D system, which can help understand linearity, force factor, etc. And also, and both of these tools are designed to help optimize the design of the speaker and overcome some of the challenges that were previously really difficult to measure. And also the Clipple scan and vibrometer. So this can measure vibration and animate it, and modal analysis of the mechanical movement of cones and surrounds and so forth. But I think Tom's definitely had more experience of this than I. So maybe you have something to add here, Tom.
Right. Yeah. In the old days, if you had a lower frequency anomaly going on with a moving system, you could use a strobe light and hope that you could see it, a little chalk dust strobe light. This obviously higher frequency, the human eye can't see that. So this will actually do a laser scan of the system in motion, and then it will provide some amplification to the motion so you can see, any problem areas. I did a tweeter 2 years ago and, saw the very apex of the tweeter dome was misbehaving. And, you can stiffen the material, you can add ribs, you can add treatments, and then, run the scan again. And, it's something we didn't have back in the day, and it's a very handy tool.
I'd love to see a comparison between like the chalk dust and the old methods versus that'd be a fantastic demonstration. There's a lot more dramatic to see the old ways than the new ones are kind of it's just perfect the first time, but the all the nuts and bolts and grease to get it done the old way is interesting. Anyways, we're in 2021.
You can imagine the amount of prototypes that would have had to be built to validate.
I mean, I know, like in consumer electronics, if you deal with people like Apple, for instance, they don't do anything without simulation. They won't and I guess you guys are the same. Like you just start with simulation and that's it. No prototype, no trial and error, I guess is the summary.
Sorry, Tom.
I was going to say it's a bit of a feedback loop, especially when you're entering material properties into the COMSOL interface, because you learn, as you go, the modulus of the material and so it's a learning process as you develop these drivers, and then of course it becomes polished and fine-tuned and gets even quicker.
Right. Yeah,
exactly. Okay. Another part of the Italian investment is we created a measurement chamber in Italy so that we could do fast measurements there as well. Not anechoic, but still good enough to do accurate enough measurements for comparison or for evaluating speakers. And then we've also got a dedicated listening room, which is, believe it or not, sometimes an overlooked aspect for pro audio speakers, because actually listening to them, I think, is very important in terms of seeing if you've hit your acoustic target, because materials, different materials might deliver a similar performance on paper, but actually on listening they sound slightly different, which is something that's really, really valuable, especially when we're trying to hit a specific target for a customer or a sonic target.
To what extent do you think that when you take a set of measured data, how perfectly does that reflect a subjective impression?
I think if you were looking, maybe Tom, you can correct me, but when you're looking at maybe compression drivers, for example, on paper you can see quite a lot of the response, and I think maybe with woofers, because of the nature of paper and materials and treatments and stuff, it can be a little bit more subjective. But I don't know if you've got more experience of that than me, Tom.
Yeah, sure, and it depends on the application. If you're working on a musical instrument speaker, those devices actually are part of the signal chain and add color to the signal, right? Guitar and bass speakers. So, you've got something that looks like a nice, the world loves to look at response curves and how linear they may be. But if a device is missing some like second order distortion on the low end, then you've lost the warmth of the performance. So like you said, the curves are not the end all. It still takes, these things at the end of the day, right? And we correlate what we see with what we hear.
Right.
So I do a bit of headphone measurement and listening myself, and the broad strokes, it's pretty clear from a measurement if something's going to sound good or not. But when it gets down to the finer detail, it's not always that easy to say, look at a curve and say, this one sounds better than that one. This.
Right. And exactly, because you can have narrow peaks or dips in the response that the human ear really doesn't pick up on those things, right? It does its own averaging. So, yeah, good point.
All right.
Okay, so I'll pass over to Tom here, because we're going to talk about a bit of a few what we consider innovations within our business at the moment. So over to you, Tom.
All right. I don't have the picture yet. Is it? There we go. Thank you. Yep. Bingo. Well, you guys have probably seen the diaphragm assembly off of a compression driver. And this is a 2-slot phase plug. And as you see in the highlighted areas, we've got, where it's snapped together. That's a typical method of assembly. You can see that there's not a uniform surface to the phase plug. And obviously at 20K, you're talking about a wavelength that's, a fraction of an inch. So these anomalies, first of all, as sections of the plug are closer to the dome, now you don't have uniform pressure under the dome in each of these areas.
Is that highlighting that some of those parts are slightly protruding and some are slightly recessed? Yeah.
Some are proud, some are recessed of there. So you've got some height variation. And that has to do with, one, tolerances of an injection molded part. Two, how these things are assembled. They're typically put together with a one-part, cyanoacrylate, and just kind of pressed, with a female tool comes down and presses those into place.
Right.
And, it's an imperfect world, and that's what you end up with in many cases. And so our solution to this, next slide there, is the integral input surface, where we're molding one piece that's on top rather than three concentric pieces. So now you've got a perfectly smooth surface, common distance to the plug, uniform pressure. Now the other thing, well, let's jump to the next slide there, Kevin, because the other thing that this affords you is now you see the pathways, which need to be equal for, proper phase response through each channel, so that the path, the wavelength are all meeting there. With this type of topology, you don't have variations in path length either. So you've got uniform pressure on the top, and then you've got nice phase cohesion on the exit side.
Mm-hmm. Yeah, and I think going back, and maybe even still today, some companies would machine that imperfect surface, Tom?
That's correct. Yeah, that's one method of doing that.
Yeah, and so this is really, it's a very simple idea that actually works for us, and it just means that we have, in terms of our production, we have more consistent devices coming off the production line, partly due to this technology, because we're taking away that risk of this high pressure input surface having any misalignments in there and causing issues on the response. So it's simple but effective.
And eliminated the need to machine. So, it's a pretty fluid process.
Okay.
Yeah.
I'm not actually all that familiar with the phase plug. You mentioned a 2-slot phase plug.
Mm-hmm. Yes,
is there a 3-slot?
This one here is a 3-slot, sir. The larger the format, the more pathways that you have.
I see. I get it now. Yeah.
Yep. Sorry. Two annular slots. There's 3.
And so traditionally they're making it in separate parts because you've got to make this tortuous path, a curved path. Yes, that's
correct. Not something that's easily molded up, as you look at that. Yeah.
Ah, very interesting. Yeah.
Now you can 3D print these for prototypes. The problem is the material's not dense enough, and of course in production you be able to keep up. So, but you for prototyping you can use like a filled material to prototype these. There's some losses associated with that because there's usually a high glass fill to this, and they've even been made of metal in some applications for density.
Okay.
Awesome.
Very cool.
Yeah, fun stuff.
Cool. Okay. All right. Well, and this shows you. Oh, this is sorry. Wake up, Kevin. This is another innovation of ours, which not technically an innovation in terms of moving the market forward, but in terms of us improving our category of compression drivers. We created a new range, which have been available over the last 2 years. And what basically was because we started out 10 years ago with a plan to develop a range of compression drivers, our approach was slightly different to how we've ended up taking this. And what we found with our first generation of compression drivers is customers were appreciating them, and we sell them a lot. But when we were being compared with some of our competitors, we were kind of missing out the mark slightly in terms of 1, price, and then 2, acoustic performance. So by no means are they bad compression drivers, our previous ones, but they just weren't getting us to where we think we should be. So our team were tasked a few years ago to really look at what we can do in terms of improving performance and also improving the cost base of our range. And they went back to the drawing board basically and analysed all of the production processes that we had adopted and really tried to find out the mechanical limits of these processes and then apply that when we were looking to achieve the acoustic target. And then ultimately, what they've done is really created an amazing range of products that put us on the map, really, for compression drivers. And we are competing with some of the best competitors on the market for HF with these units. So for us, it's amazing because we've always done very well with low frequency devices, woofers, subwoofers. And HF was a growth area for us, and we're doing very well with these. So the general trend of these is really excellent distortion management, but also all of the units have a very similar linear frequency trend, which in most cases go up to 20 kilohertz. Now, some designers might say, well, it doesn't really matter because you don't really need, you can't really hear that high, but better to have it than not. And lots of our competitors are all doing very similar responses in terms of achieving this linear frequency response. So what we have at the moment, we've got 15 models. We've got more models coming out. Anything from a 1-inch voice coil up to a 3-inch voice coil. Actually, that's wrong, up to a 4-inch voice coil, actually. And as I say, low distortion characteristic, nice, elegant designs, and linear frequency responses.
And do you have like interchangeable models, okay, now you're showing it here, either Neo or Ferrite? I know that Neo is going to be an issue for the next few months at least. So
it's already an issue. We specialize in both in most of our product categories, and obviously Ferrite has a cost advantage. And of course the magic is obviously making the Ferrite motor do a great job. It's a little bit more easier with a high power neodymium motor structure. But you can see in all of these graphs, we've got a 35 watt design here with a very linear frequency trend, 60 watt design, the Neo version here, again, very linear response. And then this is our latest edition, which is a 1.4 inch with a 3-inch coil. And again, we're getting a lot of great response from these. The price is right, the performance is excellent, and the distortion level is, in many cases, better than some of our competitors. So we have to take the hats off to our team, to be honest.
Would you mind educating me a little bit on the compression drivers? So the measurement is it running by itself in an on-axis measurement, or as a horn attached to it?
No, that's right. It's on our data sheet. It's a specified horn. So we have our aluminium horns on all of these measurements. Yeah, it's specified either a 1-inch or 1.4 inch for these horns. So it's the same horn traditionally for a 1-inch exit compression driver. We use the same horn on all measurements.
I see. And that characteristic where it slopes downwards from its fundamental resonance, whatever it is that feature of a horn's behavior? Where does that come from?
You talking about the frequency response?
Yeah. So it actually it rolls off, not rolls off, but it has a downward trend from resonance to high frequency.
Yeah, Tom, you can.
Sure.
Maybe answer this.
On any transducer, not just compression drivers, there's a region where you're fighting the mass-controlled nature of the driver.
Yep.
And then if you'll notice, we do some inductance management, but now you have a rising inductance as well that pulls the response down. So you have mass and inductance that you're being challenged, to keep the response level. And typically these devices are used with, obviously today the advent of, and affordability of DSP. There's a lot of processing that's applied, in large pro systems, column arrays, line arrays, and that, as Kevin said, that top end is there so that the designer can do with it as he chooses.
Yep.
If you guys
okay,
are
so that characteristic, that's the physics of the device rather than a design intent.
That's correct.
Yeah.
Yes. Yeah. It's as you take something, especially in the lower right, that's 3 inches in diameter. Now you're trying to get it to move at 20,000 times a second.
Yep.
You've got the inductance and the mass.
Yep.
And if you'll note, we're still at 100 decibels. 1 watt, 1 meter there. So it's pretty efficient.
It's pretty much trivial to put a filter on that to get whatever shape you want out of it in the end.
Mm-hmm. Very good.
All right.
Okay. All right. Moving on. Now Tom's going to talk about our ultra low distortion design for woofers.
Yeah, as you develop families of drivers, you use a lot of common parts for the motors, and for cost of manufacturing, ease of assembly, and so this specific design has been really optimized to lower the distortion in the unit. The sources of distortion Or, obviously, the first one is, I mentioned second harmonic. You've got third harmonic with with asymmetric coil motion. And so as you see in this, what you may not be able to see quite as easy, but there is a shorting ring applied just below the voice coil on the inside of the return path. Thank you, sir. And so that shorting ring, takes care of some distortion. You also have the advantage when we say careful management of constant inductance over excursion. You've got a very linear flux path there due to the shaped pole piece. You see there's a little T section on the top of that. A lot of motors just have a straight wall, and that provides a little bit of asymmetry at the top. So we've got a focused magnetic field. The suspension's optimized, obviously, to afford linear excursion over the range of the voice coil. This particular motor is saturated magnetically so that there's no modulation distortion. If you guys are familiar with that term, the voice coil is, a loudspeaker is actually a motor and a generator. If you drive through a restaurant, drive-through, sometimes they use the loudspeaker as the microphone. All right. So your voice is activating the cone. You're generating a signal that goes back to an amplifier. And so when a speaker is doing its thing, it's generating a back, electromotive force. And to minimize the interaction of that with the flux in the gap, you just fine tune the motor and have strong enough magnetic energy there that you cannot modulate the field in the gap itself. So that lowers that distortion component. This type of driver is used in a really high profile line array application.
Okay. Is it a challenging thing to reach the saturation field strength?
To do it evenly so that you're controlling it, it's a bit of a challenge. A lot of drivers will have what's called a choke point, a place where there's a limit to how much flux can flow through there, but that does not provide the same effect that this has. This is the entire path is saturated, and so I think that takes a lot of work in ComSol to get that optimized.
Right.
Yeah, absolutely, and a demodulating ring doesn't tend to have too much effect on the lower frequency. So this is really you can. It's quite common to manage inductance, above where the demodulating ring works, but anything below is usually quite difficult. So this really offers a flat inductance across the whole operating band of a transducer. Right. But to answer your question, in terms of it being difficult, it is challenging because you're just optimizing, standard parts of a speaker design, and it takes a lot of simulation. But of course, to achieve it in this design, especially, it also takes a lot more magnet as well to create that saturation. So they tend to be a lot more expensive than your traditional transducer.
Right, and at higher frequencies, that's where the ear's more sensitive to distortion. At lower frequencies, there's actually bass augmentation that is processed distortion at low frequency. So your ear just kind of receives that bass information, not distortion. At higher frequencies, it's very, very keen to discerning distortion. So that's add that note to Kevin's comment on the higher frequency.
All right.
All right.
And
so, go ahead, Kevin.
Sorry, Tom. No, carry on.
Oh, I was going to say this plot at first is a little difficult to fully understand, but this red line is the driver we just saw, and what's going on here is the curves are normalized at 3% THD, and so you can just see what the maximum output is at that 3% level.
Okay, so moving on, just so that we don't forget subwoofers. As I've mentioned before, we've done very well in this category, low frequency, and especially subwoofers, because we're delivering product that is impressive, reliable, consistent, does what it says, But we're also very much involved. We're now doing 21-inch with 5.3-inch voice coils which are pretty high performance designs. And more recently, we're now looking at low impedance designs. So traditionally, subwoofers would be 8 ohm or 4 ohm, for example, whereas this 18 is a 2 ohm design, but it's designed for real high performance applications. So in this speaker, we've also adapted this ultra low distortion design in terms of flat inductance, excellent distortion management, and also part of the benefits of that, with such a good thermal design, it has excellent power compression. So this is a 2 ohm design, 4.5-inch coil, with a specified X max of nearly 20 millimeters. So it's an impressive beast, and being 2 ohm, lots of people can make full use of their amplifier's capabilities. So it should be an interesting one, especially in distribution for us.
Would you just mention briefly what's the difference or advantage of 2 ohm versus 8/4?
Well, amplifiers can work at a specified impedance or optimize at a specified impedance. So some amplifiers are still stable at low impedance. So you can, traditionally, if you've got an amplifier and you want to run a double 18, but you can only find 8 ohm woofers, that's the trick. You can only create a 4 ohm load. Whereas what we're offering here is you can, if you've got an amplifier that works stably at 2 ohms, you can add one of these onto your amp and get the full benefit of the amplifier. It's only one. It's a part of the market, especially in the DIY, sound system scene, where people are making their own cabinets and stuff, where it could be quite attractive for these guys to have such a low impedance, extreme type of subwoofer design. But yeah. Okay, and then, all right. So that's kind of our R&D and some of the innovations and technologies that we've been doing. And we'll now dive into our facility in China. So here's an overhead view, and it's this was purpose built by us in 2014. So it has lots of space available for expansion. And you can see on the left, the white building here is the warehouse, factory, management offices, engineering offices, and then the staff quarters behind. And then you can see the obligatory basketball court. But we employ around 325 people here, and it's an ISO 9001 accredited facility. So it's an impressive place. Once and you guys are always welcome, obviously, to come and visit.
Yeah, as soon as the border opens.
Yes. Yeah, although if you speak to people in China, everything's normal.
Yeah, I know. Just from Hong Kong, normally we'd go 3 days a week at least into the factories, but now we just sit and talk on Zoom for the last year.
Yeah, I think that's all of our world at the moment.
Totally.
So in terms of our engineering department, we obviously have project teams managing the production process, but we also have on-site electroacoustic engineers to aid with, projects and so forth. One thing that we're missing, obviously, at the moment is we normally have our Italian colleagues there helping things along. And so, one of the challenges we've had is obviously to maintain momentum in our development process without having the Italians on site, and which we're managing. But of course, it's much easier when we've got the hands-on guys there. And in terms of our team, we've got a dedicated sampling team, testing department, and I'll talk about those in a second. And of course, the facility is equipped with Clipper R&D and also their quality control system, which I'll talk about as well.
All right.
So in terms of measurement capability, we have a very nice semi-anechoic chamber on site, which was co-designed with Nanjing University, which is a well-known acoustics academy, if you like. And this is a controlled environment, humidity and temperature controlled. And it's designed with quick change panels in the floor, and obviously we can do off-axis responses all at the same time. So it's a really practical, environment, and good environment for measurement. For power and life testing, last year we finished a new building on site, which houses our power and life testing. But it was done in 2 adapted containers in the car park. Now it's a dedicated, slicker environment, obviously a bigger space. And we run our 2-hour AES power tests and a 100-hour life test on our products as part of the validation process. All we use power soft amplification. And
just a note I find interesting. A lot of people watching, they might think, oh, in a sea container or something, you're building part of your factory. That's quite normal with factories. It's have modular automated painting lines inside sea containers. So
really?
Oh yeah, it's like so just to be modular. It's this kind of lean and mean manufacturing. So everybody watching, this is kind of normal stuff in China.
Well, this isn't. I mean, this is what we used to use, but This is a building that we finished last year. Was as a dedicated building because we needed the ability to do more measurements. Without, we could have added another container, but and they work very well, but this is a much better environment.
Sure. Okay.
And to do these measurements, we use Clipple Power Monitor 8 and True Technologies equipment and software. And this enables us to do 56 speakers measurements at the same time. Now, it doesn't mean we can do 56 different measurements because usually you might want to do the same test on a multiple of speakers. But we have enough capability to meet our demand, in terms of measurements and stuff. And these systems, generally are real-time measurement of loudspeaker parameters. So when things do go wrong or the speaker fails, we know what caused it quite quickly by the data that these systems give us.
Okay.
So I know, Tom, you've used some of this equipment before, haven't you? In your previous lives?
Yeah, it's real handy for, obviously with a driver under a life test, you're looking for a certain amount of break-in. So if the resonance of the driver is falling too far, below, an expected percentage, say, 10%, then you would stop the test, And obviously, if you're having some kind of failure, as Kevin indicated, it shows up very quickly.
Mm.
Okay.
And also, we are finalizing our testing building. So previous to this, we had kind of testing machinery dotted around the factory. And actually, because of the partnerships that we have with some of our customers, and to meet their requirements in terms of testing, because obviously it does vary the expectations of some of our customers. And we deal with some of the most demanding. So we've decided to make some significant investment in, again, with a dedicated building just for testing, and also to consolidate existing equipment, but also to add some new equipment to make us cutting edge when it comes to validating and meeting our customers' expectations.
I like that you have the IP6, which is the dust specification, which would probably be for our Burning Man or Coachella type PA speakers to see how they handle the dust protection.
Oh, I think I'll use that next time I talk to my customers.
Sure.
But yeah. I mean, we also have a really nice range of marine speakers as well with the car audio side. So we've not progressed into that. I mean, there is a certain amount of waterproofing requirement for pro audio, of course. But not quite the same as marine. But.
Yeah, but dust is a thing that's impacted in pro and in a nightclub or at an outdoor event. Dust is a much bigger problem than in the consumer world of audio.
Yeah, no, you're absolutely right.
We find some of our speakers in applications that we never dreamed. We have some in currently in a wireless system in a consumer good.
Wow.
That IP6 rating applies there as well. Musical instrument, portable PA. So it's very important criteria for some of our customers.
Yeah. PA sitting in a moldy old bar just tend to get dirty.
Yeah.
Exactly. Okay, we move on. The next slide's about our IQC. Of course, this is an immensely important part of our management and quality control. So every component that comes into the building is followed with a quality control procedure, so that we can validate all of those parts before we move them into production. So it's a really a part that we talk about a lot. That's really critical in making us successful.
Okay.
And in terms of finished product quality control, every single speaker that we produce is tested using a Clipple QC system, which is a quality management system that records the performance of the speaker as it comes off the production line. And that information is then linked with a barcode that we barcode on each speaker, so that we know exactly what the performance was of the speaker when it left our facility.
Mm-hmm.
And then we also run voice core positioning, sweep tests, resonance, etc. And of course, batch testing on production batches. So it's, unexpected, but we care a lot about these aspects because that's what's, making us successful ultimately.
Okay.
In terms of warehousing, we generally warehouse at our facility in China. So we carry a lot of our standard items in stock and some of our customized products for our customers. We at this time, we don't generally stock LaVoce in Italy, but we're looking at various other, warehousing plans globally at the moment. So watch this space. But we tend to do very well out of this location because we invest a lot in inventory to make sure that we can meet the demands of our distributors and customers that are taking standard products. And it's operated with a first in, first out, policy, and everything is, not right. We know exactly where everything is in the warehouse because it's managed by radio frequency, etc.
Are speakers something that's within the tax issues going into the U.S. as a standalone transducer? Is that an issue for tax for people importing?
Yeah, I think it's not as a component for manufacturing. It's not as highly taxed as the finished system is.
Okay.
Yeah. So for us, the impact has not been too bad because it's not a very high percentage compared to a finished system, because obviously that's trying to protect manufacturing in the USA. But as a component part, it's been manageable, thankfully, for us.
Okay.
Yeah. So a couple of slides just to summarize. This is where LaVoce strengths lie. We make woofers to be used with a high frequency device, 3-inch to 15-inch, 30 watts to 600 watts kind of power handling. Mid ranges, 5-inch to 10, dedicated for that type of application. Subwoofers, we do 8-inch all the way up to 21-inch with a 2000 watt AES power handling. So serious stuff. Yeah. And then full ranges, we do 2-inch, 3-inch and 4-inch. And we're very successful in this category because it's the products do very well for pro audio applications, column arrays, that type of design. Compression drivers, we've already touched base with. We even do a little 0.75-inch exit compression driver, which is, minuscule, 45 millimeters in diameter. Mm-hmm. All the way up to 2-inch exit designs. Coaxials, we've got 5 and a 6 in our range at the moment, but we're working on this category as we speak in terms of delivering some high performance products. Tweeters, we do 1-inch and 1.3-inch designs, which are very nice. They're really nice frequency responses and good for some pro applications. And of course, we can't forget bass and guitar. Bass guitar we're actually quite successful in, because bass guitar is an extension to a pro audio speaker. Mm-hmm. And it's there's still some serious business that can be had in the MI sector for guitar amplifiers and so forth. So it's a category that we still respect, if you like. So in summary, Lavoce is a place where we design HF and LF transducers and manufacture for the pro audio and MI industry. The brand was launched in 2012, so technically we're 9 years old as a brand. So we feel we've done a lot in that time in terms of raising our profile as a serious competitor. To summarize our business, 85% of our sales are really to manufacturers, for customers that are designing their own cabinets and so forth. And that will always remain our core business. But we also have a growing distribution business, which satisfies a need for people designing their own sound systems and small manufacturers. And depending on which markets you look at, that can be quite big business, especially in South America and India, for example. Actually, we do very well in Vietnam and Indonesia in this respect as well. We exhibit ISC, Pro Light and Sound, the Frankfurt, Guangzhou and Shanghai, and also the NAMM show, and a local show in Italy, which we like to show our support for the local business, Music Inside Rimini. And we're just about to launch our new catalogue, should be available sometime in April in PDF format, which will have lots of other new products in, so we're in an interesting growth phase for the company with lots of good stuff to talk about. So, yeah, okay. And there we go.
All right. Well, let's.
Thank you very much, gentlemen.
Go back to talking to us. All right. So, yeah, that's a lot of information, a good kind of update, and I guess kind of online brochure now for Lavoce, so everybody to learn about the company But don't forego a visit to Shanghai or Italy if you need to meet these guys.
Hey, one thing, Kevin, just before we call it a day. You're selling a lot to other manufacturers putting the speakers into their cabinets. Do you still get brand recognition? Do people know that it's a Lavoce driver in that product?
Oh, it's an interesting thing. I think time is the thing that makes your speaker recognizable. So go back 5 years, I think people wouldn't have recognized a Lavoce basket or a Lavoce rear cover for a compression driver. But now that our brand recognition is a lot higher than it was, let's say, 5 years ago. The industry, I strongly believe, now recognize a Lavoce speaker in a cabinet. Yes. When we speak with distributors and so forth, inherently a lot of those already know us because they're distributing a brand that's already using Lavoce, and they may have been told by that brand what the speaker is, or and that word of mouth tends to gradually get out into the marketplace, so everyone becomes a bit more familiar with how our products look.
Yeah, I don't know much about Pro, but I can imagine in that space, the end customers are interested in which drivers are in the cabinets more so than perhaps home audio people. There's just a speaker. The brand is who have made the final cabinet,
Yeah. I think there's a validation, isn't there? Interestingly, we obviously like people knowing that Lavoce has been used in the cabinet, but of course lots of our customers don't talk about that because they're talking about the whole system design, which is absolutely fine. But I think a lot of the end users want reassurance that the speaker is something that's has validation in terms of it being good enough to what it does. And I think, we've got a little way to go, but I think the market definitely sees LaVoce as an equal in many respects to some of our European competitors, So, but we keep on striving. We keep on working on our marketing and trying to raise the brand profile and so forth. And I think it's working. So.
All right.
Thanks.
Well, good stuff. I think that was a very comprehensive view into the world of LaVoce. So I think maybe we'll call it there for this episode. So everybody, please hit your comments below. We'll make sure any questions and everything get in front of Tom and Kevin here, so they can answer your questions from the universe of YouTube. So also like, subscribe, and share and amplify the podcast. So all right, thanks for watching, everybody. Bye-bye.
Thanks, guys.
Thanks, guys. Ciao.